Have you ever stood beneath the stars and felt impossibly small? Not just physically small, but temporally small. A brief flicker in an expanse of time so vast, it makes your entire existence feel like a rounding error. You live for maybe 80 years if you're fortunate, maybe 90 or even 100. But the universe has been here for 13.8 billion years. Your entire life, from your first breath to your last, occupies less than 1/1,000,000th of cosmic history. If you compress the entire age of the universe into a single year, all of human civilization would fit into the last 10 seconds before midnight on December 31st. And your personal life, your individual existence, it would last less than a millisecond. A camera flash in an eternal night. Tonight, we drift into that incomprehensible scale, into the dizzying mathematics of time itself, to understand not just how brief we are, but what it means to exist as a mathematical error on the cosmic calendar. So close your eyes. Let the weight of eternity press gently against your chest and follow me into the humbling perspective of deep time. Before we begin, if you're kind enough, a gentle like or a quiet tap on subscribe would mean the world to me. It's a small gesture, but I hold it with deep gratitude because every bit of your support keeps this tiny universe alive and reminds me that these quiet stories still find their way to gentle hearts like yours. Now, let's begin with the first question. Part 1. The mathematics of insignificance. Let's start with something simple. A human lifetime. According to the World Health Organization, the global average life expectancy is about 73 years, though it varies significantly by country and circumstances. In developed nations, many people live into their 80s or 90s. Let's be optimistic and use 80 years as our reference point. That's 80 trips around the sun, 80 springs, 80 winters, about 29,200 days, or roughly 700-800 hours. That sounds like a lot. It feels like a lot when you're living through it. Now let's zoom out. According to NASA's Goddard Space Flight Center and measurements from ESA's Planck satellite, the universe is approximately 13.8 billion years old. That's 13,800,000 years. To make the comparison clearer, let's do some mathematics. If we divide a human lifetime of 80 years by the age of the universe, we get 0.58. Or, to put it in more familiar terms, your entire life represents 0.0% of cosmic history. That number is so small it's almost meaningless to our minds. We didn't evolve to comprehend fractions that tiny. So let's try some analogies, ways of scaling time that might make the comparison more visceral, more real. Imagine the entire 13.8 billion year history of the universe compressed into a single calendar year. January 1st at midnight represents the Big Bang. December 31st at midnight represents now, this very moment. On this cosmic calendar, according to calculations popularized by Carl Sagan in his series Cosmos, the Milky Way galaxy forms around March. Our solar system, including Earth, doesn't appear until September. The first simple life on Earth emerges in late September. But complex multicellular life doesn't arrive until mid-December. Dinosaurs? They don't show up until December 25th, Christmas Day, and they go extinct on December 30th. All of human evolution, from our earliest ancestors to modern humans, occurs in the final hours of December 31st. Written history, everything from the first civilizations to the present day, occupies only the last minute before midnight. And your personal lifetime? It lasts about 0.15 seconds, less than the time it takes to blink. Let me put that another way. If the entire history of the universe were represented by the distance from Los Angeles to New York, roughly 2,800 miles, a human lifetime would be about the width of a human hair, approximately 0.01 inches. You could walk from the Big Bang in Los Angeles to the present moment in New York, and you wouldn't even notice the microscopic segment that represents your entire existence. Or consider this: if you started counting seconds from the Big Bang, one per second, it would take you 437 billion years to count to 13.8 billion years worth of seconds. You'd need to count continuously, without sleep or pause, for longer than the universe has existed, just to enumerate the seconds it has already existed. Meanwhile, a human lifetime of 80 years contains about 2.5 billion seconds. That's a large number, but it's nothing compared to the 435 WEKX in our 17 seconds since the Big Bang. These comparisons might seem abstract, but they reveal something profound. According to the laws of physics and the measurements of cosmology, you are temporally negligible. Your existence, no matter how important it feels to you, occupies an infinitesimal fraction of time. You are not even a footnote in cosmic history. You are a rounding error, a measurement uncertainty, a statistical fluctuation. The James Webb Space Telescope captures light from galaxies that formed when the universe was less than 400 million years old. That light has been traveling toward us for over 13.4 billion years. During the entire journey of those photons, from their emission to their detection, countless stars have been born and died. Galaxies have collided and merged, and your entire life from birth to death will have occurred in a time span that represents less than 0.6% of that single photon's journey. ESA's Gaia mission has mapped over 1 billion stars in the Milky Way, revealing their positions and motions. Many of these stars are billions of years old, ancient before Earth even existed. They will continue burning for billions of years after humanity is gone. Compared to these stellar lifetimes, human existence is not just brief, it's practically instantaneous. But here's what makes this even more humbling. Your conscious awareness, your moment-to-moment experience of being alive, is even briefer. According to neuroscience research published by institutions like MIT and the National Institutes of Health, the brain processes information in windows of roughly 100-200 milliseconds. That's how long it takes for sensory information to become conscious perception. Your subjective experience of now, the present moment, lasts about 1/10 to 1/5 of a second before it becomes the past. So not only is your 80-year lifetime negligible on cosmic scales, but the actual lived experience of that lifetime, the sum total of all your now moments, consists of discrete chunks, each lasting a fraction of a second. You don't experience time as a smooth continuum. You experience it as a rapid sequence of snapshots, stitched together by memory into the illusion of continuity. From the universe's perspective, if it could have one, you don't live 80 years. You live 80 years worth of 200 millisecond moments, and then you're gone. You are a brief pattern of matter and energy that emerged, persisted for a cosmically insignificant duration, and dispersed back into the void from which it came. As physicist Brian Greene once wrote, "We are all ephemeral. Our lives are mayflies in cosmic terms. But even calling us mayflies is generous. A mayfly lives for a day. Compared to the universe, we don't even live that long." Take a slow breath. Right now, as you read these words, the universe is 13.8 billion years old and counting. It will continue for trillions upon trillions of years, possibly forever. You will be here for maybe 80 of those years. You are living in a sliver of time so thin it barely exists. You are temporally insignificant, a mathematical error on an infinite timeline. And yet, here you are, aware, conscious, capable of understanding your own insignificance That paradox is what makes this exploration both humbling and strangely meaningful. And as we continue, we'll see just how recent our arrival really is. Part 2. How recently did humans appear? If human lifetimes are insignificant on cosmic scales, human existence as a species is barely more substantial. We think of ourselves as ancient, as established, as if we've been here forever. We build monuments, write histories, create civilizations that we imagine will endure. But from the universe's perspective, we just got here. We're not even unpacked yet. According to paleontological evidence and genetic studies compiled by institutions like the Smithsonian and the Max Planck Institute, anatomically modern humans, Homo sapiens, emerged around 300,000 years ago in Africa. That's when our species, with our particular body structure and brain capacity, first appeared. Behaviorally modern humans, with language, art, and complex tools, emerged somewhat later, perhaps 70,000 to 100,000 years ago. Let's use 300,000 years as our starting point. That sounds old. It is old by human standards. It encompasses the entire history of our species, from our first appearance to this present moment. But let's compare it to cosmic timescales. The universe is 13.8 billion years old. Earth formed about 4.54 billion years ago, according to radiometric dating of ancient rocks and meteorites, analyzed by NASA and the United States Geological Survey. Life appeared on Earth relatively quickly, perhaps as early as 3.8 billion years ago, when the planet's surface cooled enough for liquid water to exist. Complex multicellular life didn't emerge until about 600 million years ago, and anatomically modern humans, 300,000 years ago. Do the math. Humans have existed for 0.0% of Earth's history. We've been here for 0.0 of the universe's history. If Earth's 4.54 billion year history were compressed into 24 hours, humans would appear in the last 6 seconds. If the universe's 13.8 billion year history were compressed into 24 hours, humans wouldn't appear until the last 0.6 seconds before midnight. Carl Sagan's cosmic calendar makes this even clearer. On that calendar, where the entire history of the universe fits into 1 year, anatomically modern humans don't appear until December 31st at 11:52 p.m. We've existed for the last 8 minutes of the cosmic year. Everything we think of as history, the rise of agriculture, the building of pyramids, the Roman Empire, the Renaissance, the Industrial Revolution, the Space Age, all of it happens in the final 21 seconds. The James Webb Space Telescope has captured images of galaxies that formed when the universe was less than 400 million years old, roughly 13.4 billion years ago. Those galaxies were already billions of years old when Earth formed. They were ancient beyond measure when the first life appeared on our planet, and they were incomprehensibly old by the time humans evolved. From their perspective, if galaxies could have perspectives, humans are a brand new phenomenon, so recent we barely register. ESA's Planck satellite measured the cosmic microwave background, the afterglow of the Big Bang, showing us the universe as it was just 380,000 years after its birth. That snapshot captures a universe before stars, before galaxies, before anything we'd recognize as structure. And yet, that ancient primordial universe existed for longer, 380,000 years, than humans have existed, 300,000 years. The universe was already old when it became transparent to light, and it was incomprehensibly older by the time we arrived. But even within Earth's history, we're newcomers. The dinosaurs dominated the planet for about 165 million years, from the Triassic through the Cretaceous periods. According to fossil records studied by institutions like the American Museum of Natural History, dinosaurs existed for 550 times longer than humans have. If the entire 165 million year reign of the dinosaurs were compressed into a single human lifetime of 80 years, all of human existence would fit into the last 53 days. We haven't even been here for 2 months in dinosaur terms, and dinosaurs themselves were not early life. They emerged about 230 million years ago, long after complex life had already diversified. Simple bacteria have existed on Earth for at least 3.5 billion years, according to fossil evidence from Western Australia and Greenland. Bacteria have been here 11,666 times longer than humans. If bacterial history were compressed into 80 years, humans would have appeared approximately 6 hours ago. Let's zoom in further. Civilization, what we think of as recorded history, is even more recent. Agriculture, the domestication of plants and animals, began only about 10,000 years ago in the Fertile Crescent. Cities emerged around 6,000 years ago. Writing was invented about 5,000 years ago in Mesopotamia. All of history, everything you learned in school, every empire, every war, every philosophical breakthrough has occurred in the last 5,000 years. On Sagan's cosmic calendar, all of recorded history occupies the last 10 seconds before midnight on December 31st. The pyramids of Giza were built 9 seconds before midnight. The Roman Empire rose and fell in the last 5 seconds. The Renaissance happened 1 second ago. The Industrial Revolution, World War I, World War II, the moon landing, the internet all occurred in the last 0.5 seconds. And you? Your personal lifetime? On the cosmic calendar, where civilization itself lasts only 10 seconds, your 80-year life lasts about 0.15 seconds. That's 150 microseconds. The human eye blinks in about 100,000 microseconds. You live for 1.5 blinks on the cosmic calendar. NASA's Hubble Space Telescope has observed galaxies colliding, processes that take hundreds of millions of years. During the collision of the antennae galaxies, an event that began about 300 million years ago and will continue for hundreds of millions more, humans evolved from nothing, built civilizations, and will likely go extinct, all within the time it takes for 2 galaxies to merge. We are background noise in galaxy collision timeframes. Even the Sun, our closest star, puts our recency in perspective. According to NASA's Solar Dynamics Observatory, the Sun is about 4.6 billion years old, middle-aged for a star of its type. It will continue burning for another 5 billion years before exhausting its hydrogen and beginning its red giant phase. In the Sun's lifetime, from birth to death, humans will have existed for 0.003% of it. The Sun was already 4.6 billion years old when we appeared, and it will shine for another 5 billion years after we're gone. This recency has implications. According to the Fermi paradox proposed by physicist Enrico Fermi, if intelligent life is common in the universe, we should have detected it by now. But one explanation for the paradox is timing. The universe is 13.8 billion years old. Intelligent life on Earth emerged just 300,000 years ago, and technological civilization just 200 years ago. If other civilizations evolved on similar timescales, the chances of 2 civilizations existing at the same time in the same region of space are astronomically small. The universe is so old that civilizations might rise, flourish, and disappear in non-overlapping windows of time, never knowing the others existed. We are not just spatially isolated, separated by vast distances between stars and galaxies. We are also temporally isolated, appearing at a random moment in cosmic history when most of the universe's past is already behind us, and most of its future stretches ahead. Take a quiet breath. Humans have been here for 300,000 years. That's 150 human lifetimes, stacked end to end. It feels like a long time, but the universe has been here 46,000 times longer. We arrived yesterday in cosmic terms. We unpacked our bags this morning and will likely be gone by tomorrow. And as we sit with this uncomfortable recency, another question emerges. If we just arrived, and if we're only here for a blink, what came before us? How much did we miss? That's where we turn next. Part 3. What happened before we existed? For 13.8 billion years, the universe existed without us. Stars formed, lived, and died. Galaxies collided and merged. Planets were born from swirling disks of gas and dust, cooled, developed atmospheres, and some, perhaps many, harbored life. All of this happened without a single human to witness it. The overwhelming majority of cosmic history occurred before we arrived, and we missed it. Let's trace that history. According to ESA's Planck satellite and NASA's WMAP mission, the universe began 13.8 billion years ago in an event we call the Big Bang. In the first fraction of a second, the universe expanded exponentially during a period called inflation, growing faster than the speed of light. By the time inflation ended, the universe had cooled enough for particles to form, first quarks and gluons, then protons and neutrons, and eventually, about 380,000 years after the Big Bang, the first atoms. That first 380,000 years is called the Dark Ages, not because the universe was dark, but because it was opaque. Light couldn't travel freely. It scattered constantly off the dense plasma of particles. Only when the universe cooled enough for atoms to form did it become transparent. The cosmic microwave background, that faint glow detected by Planck and WMAP, is the light from that moment, the oldest light in the universe, now stretched by expansion into microwaves. The first stars didn't form until about 100 to 200 million years after the Big Bang. According to observations by the James Webb Space Telescope, these early stars were massive, hot, and short-lived. They burned through their fuel in just a few million years, then exploded as supernovae, seeding space with the first heavy elements: carbon, oxygen, iron. These elements, forged in stellar cores, would later become essential for life. The first galaxies assembled around 400 million years after the Big Bang. JWST has captured images of these primordial galaxies, small and irregular, nothing like the majestic spirals we see today. They were violent places filled with young stars, frequent supernovae, and actively feeding black holes. Over billions of years, these early galaxies merged, growing larger and more structured. Our Milky Way began forming about 13 billion years ago, when the universe was less than a billion years old. According to ESA's Gaia mission, which has mapped over 1 billion stars, the Milky Way grew through mergers, absorbing smaller galaxies over time. Some of the oldest stars in our galaxy are nearly as old as the universe itself, ancient beyond human comprehension. But even as galaxies formed and evolved, Earth didn't exist yet. Our solar system formed much later, about 4.6 billion years ago, according to radiometric dating of meteorites and lunar rocks. The Sun ignited as a star, and the planets condensed from the remaining disk of gas and dust. Earth started as a molten ball, bombarded by asteroids and comets, slowly cooling until liquid water could exist on its surface. Life appeared surprisingly quickly after that. According to fossil evidence from Western Australia, simple single-celled organisms existed by at least 3.5 billion years ago. For the next 3 billion years, life remained simple. Bacteria, archaea, eventually simple eukaryotic cells. Earth was a microbial world, a planet of slime and algae, without plants, without animals, without anything we'd recognize as complex. The first complex multicellular life emerged about 600 million years ago during the Ediacaran period. These were strange organisms, soft-bodied and alien, preserved in rocks from Australia and Namibia. They didn't last long. The Cambrian explosion, 541 million years ago, brought a sudden diversification of life, the emergence of most major animal groups in a geological blink. Fish appeared, then plants colonized the land, insects followed, amphibians crawled out of the water, reptiles evolved, and then, 230 million years ago, the dinosaurs arrived. They dominated Earth for 165 million years through the Triassic, Jurassic, and Cretaceous periods, until an asteroid struck 66 million years ago, ending their reign and opening the way for mammals to diversify. Primates emerged about 55 million years ago. Early apes appeared 20 million years ago. The human lineage split from chimpanzees about 6 to 7 million years ago. Our genus, Homo, emerged about 2.5 million years ago. Homo erectus, the first of our ancestors to leave Africa, appeared about 1.9 million years ago. Neanderthals, our close cousins, emerged around 400,000 years ago. And then, finally 300,000 years ago, anatomically modern humans, Homo sapiens, appeared. We missed everything before that. We weren't there when the first stars ignited. We didn't see the Milky Way form. We weren't present when Earth cooled or when life first emerged. We missed the entire age of dinosaurs, the Cambrian explosion, the colonization of land. All of it happened without us. According to calculations based on the cosmic timeline, 99.9998% of the universe's history occurred before humans existed. If you imagine the universe's lifespan as a 1,000-page book, humans don't appear until the last 2 words on the last page. Everything before, the entire narrative, the rise and fall of countless stars, the formation of billions of galaxies, the evolution of life on Earth through countless forms, all of that happened in our absence. NASA's Kepler, Space, Telescope, and TSS mission have discovered thousands of exoplanets, many of them billions of years older than Earth. Some of these planets formed when the universe was less than 1 billion years old, around 12 or 13 billion years ago. If life emerged on any of those worlds, it had a 12 billion year head start on us. Civilizations could have risen, flourished, and disappeared billions of years before Earth even existed. We are not early. We are late. Incomprehensibly late. The universe had been running for 13.5 billion years before we showed up. It had already gone through its formation, its childhood, its maturation. By the time we arrived, the universe was middle-aged, past its peak of star formation, entering a long, slow decline toward darkness. And here's the haunting part. We'll never know what we missed. We can observe the after effects, the cosmic microwave background, ancient galaxies, fossil stars, but we can't witness those early eras directly. The light from the most distant galaxies shows us their past, but not ours. We can study rocks and fossils to understand Earth's history, but those are traces, shadows, not the events themselves. The universe existed without witnesses for 13.8 billion years. It didn't need observers. It didn't need consciousness. It simply was, unfolding according to the laws of physics, stars burning, galaxies colliding, life emerging and evolving, all without anyone to marvel at it. As physicist Sean Carroll writes, "The universe doesn't care whether you're watching. It existed before us, indifferent to our absence. It will continue after us, equally indifferent to our passing. We are incidental to cosmic history, a brief interruption in an otherwise unobserved expanse of time. Take a slow breath. For 13.8 billion years, reality unfolded without you. Stars lived entire lifetimes. Galaxies formed and merged. Earth cooled. Life emerged. Dinosaurs came and went. And you weren't there for any of it. You missed almost everything. And what you did arrive for, you'll only witness for a fraction of a second before it's over. And that brings us to the next humbling realization. If we've already missed most of cosmic history, what will happen after we're gone? How much will the universe continue without us? That's where we drift next. Part 4. What will happen after we're gone? If the past is vast, the future is incomprehensibly larger. The universe has existed for 13.8 billion years. That's a long time. But according to our best understanding of cosmology, the universe will continue for trillions upon trillions of years, possibly forever. Everything that has happened so far, the entire history from the Big Bang to now, is just a tiny prologue to a story so long it makes eternity seem brief. Let's start with humanity's likely lifespan. This is speculative, but we can make educated guesses. Our species, Homo sapiens, has existed for 300,000 years. Most species last between 1 and 10 million years before going extinct or evolving into something else, according to paleontological data. Let's be optimistic and assume humans, or our descendants, survive for 10 million years. That's still only 0.7% of the universe's current age. It's nothing. But even if we survive far longer, even if we colonize other stars, other galaxies, even if we persist for 1 billion years, we're still just a blip. The universe will outlast us by incomprehensible margins. According to NASA's observations and ESA's Planck satellite, the universe is not only expanding, it's accelerating. Dark energy, a mysterious force that makes up about 68% of the universe's energy, is driving this acceleration. Galaxies are moving apart faster and faster, and this expansion will continue indefinitely. The universe is not heading toward a big crunch where everything collapses back together. It's heading toward a big freeze, a state of cold, dark, infinite expansion. In about 5 billion years, according to NASA's Solar Dynamics Observatory, our sun will exhaust its hydrogen fuel and begin expanding into a red giant. It will swell to the orbit of Venus, possibly engulfing Earth, or at least rendering it uninhabitable. Life on Earth, if it still exists, will end. The sun will eventually shed its outer layers, leaving behind a white dwarf, a cooling ember. It will gradually fade over billions of years. But the universe will continue. Other stars will still burn. Smaller stars, red dwarfs, can last for trillions of years. According to astrophysical models, the last conventional stars will form around 1 trillion years from now. After that, star formation will cease because the universe will have exhausted its supply of hydrogen, the fuel for stars. In about 100 trillion years, the stelliferous era, the age of stars, will end. According to research by cosmologists including Fred Adams and Gregory Laughlin, by this point, most stars will have burned out, leaving behind white dwarfs, neutron stars, and black holes. Galaxies will have dispersed, their stars slowly drifting apart due to gravitational interactions. The universe will grow dark and cold. Around 10 to the power of 40 years from now, even white dwarfs will have cooled into black dwarfs. Cold, dark objects no longer emitting light. Neutron stars will remain, but they'll be invisible, detectable only by their gravity, and black holes will have grown, consuming stars and merging with each other, becoming the dominant structures in the universe. But even black holes aren't eternal. Stephen Hawking predicted that black holes evaporate through quantum radiation. A solar mass black hole would take about 10 to the power of 67 years to evaporate completely. Supermassive black holes, the giants at the centers of galaxies, would take around 10 to the power of 100 years. These timescales are so vast that calling them long is meaningless. They're essentially infinite from any human perspective. After the last black hole evaporates, the universe will enter the dark era. It will consist almost entirely of photons and lightweight particles, spread so thinly across space that the average density will be close to zero. The temperature will be effectively absolute zero. Nothing will happen. The universe will reach a state of maximum entropy, heat death, where no energy is available to do work, where time loses meaning because nothing changes. This is the timeline that awaits. The universe will continue for 10 to the power of 100 years, possibly longer, possibly forever. Humanity, if we're extraordinarily successful, might last 10 million years. That's 0.0% of the universe's future, assuming we count only to 10 to the power of 100 years. If the universe is truly infinite in duration, then our existence, no matter how long, occupies 0% of eternity. Let's scale this. If the universe's future, from now until 10 to the power of 100 years, were compressed into a human lifetime of 80 years, humanity's remaining existence, even if we last 10 million years, would be 0.001 seconds. That's 10 femtoseconds. Light travels only 3 microns in 10 femtoseconds, less than the width of a human cell. From the perspective of deep time, we are not even here. We exist for a duration so brief that the universe wouldn't notice if we disappeared, and we will disappear, either gradually through evolution into something else, or suddenly through extinction. Either way, the universe will continue without us, just as it existed without us for 13.8 billion years before we arrived. The James Webb Space Telescope has captured images of galaxies that will exist for trillions of years. Stars within those galaxies are being born right now and will burn long after the sun has died. Some of those stars will outlast our entire solar system. According to ESA's Gaia mission, red dwarf stars, the most common type, can burn for 10 trillion years. They will be shining long after every trace of human civilization has eroded away, after Earth itself has been consumed by the dying sun, after the sun has cooled into a black dwarf, after the Milky Way has dispersed. Even more humbling, the atoms that make up your body will outlast you by incomprehensible margins. According to particle physics, protons, the building blocks of atomic nuclei, might decay, but if they do, the process takes at least 10 to the power of 34 years, far longer than the current age of the universe. Your atoms are essentially eternal. They existed before you were born, incorporated into rocks, oceans, other living things. They will exist after you die, recycled into soil, air, water, perhaps other organisms. The matter you're made of will be here for trillions of years. You, the pattern that matter briefly forms, will not. As cosmologist Brian Greene writes, we are all temporary patterns in the flow of matter and energy. That pattern, that arrangement of atoms we call you, will dissolve, but the universe will continue, indifferent, following the laws of physics toward cold, dark equilibrium. And here's the final twist. Even if humanity survives, even if we colonize the galaxy, even if we become a spacefaring civilization that lasts for millions or billions of years, we will witness only a tiny fraction of cosmic time. The universe's future is so vast that even a civilization lasting 1 billion years would experience less than 0.1% of it. The overwhelming majority of cosmic time will unfold without any observers at all. a dark, cold, empty expanse where nothing happens and no one is there to see it. The universe doesn't need witnesses. It existed before consciousness emerged. It will continue long after consciousness disappears. We are incidental, a brief experiment in complexity during the universe's middle age, before the long descent into darkness. Take a long, slow breath. You will die. Humanity will go extinct. The sun will burn out. The stars will fade. Black holes will evaporate. And the universe will continue, empty and cold, for incomprehensible spans of time. Everything that has meaning to you, everything you care about, exists in the tiniest sliver of time, a fraction so small it's essentially zero. And yet, here you are, alive, aware, capable of understanding your own insignificance. That paradox is what makes the final question so compelling. Part 5. What does it mean to be a cosmic blink? So we've traveled through the mathematics of insignificance. We've seen that a human lifetime is 0.058% of cosmic history, that humans have existed for 0.217% of the universe's age, that 99% of the past happened without us, and 99.999% of the future will happen without us. We are temporally negligible, mathematically insignificant, cosmic rounding errors. This realization can feel crushing. If you're so brief, so recent, so temporary, what's the point? Why does anything you do matter if the universe will forget you in less time than it takes to blink? Why strive? Why create? Why love? If it all disappears into the same vast darkness that claimed everything before you and will claim everything after? These are not new questions. Philosophers have wrestled with them for millennia. The ancient Greeks spoke of the brevity of life. Marcus Aurelius, the Roman emperor and Stoic philosopher, wrote, "You could leave life right now. Let that determine what you do and say and think." He understood that life is short, that we exist for only a moment, and that this brevity should inform how we live. But there's another way to see it, one that doesn't lead to despair or nihilism. The fact that you're temporally insignificant doesn't mean you're meaningless. In fact, it might mean the opposite. Carl Sagan, who spent his life studying the cosmos, wrote, "We are a way for the universe to know itself." For 13.8 billion years, the universe existed without consciousness, without observers, without anything capable of reflection or wonder. Stars burned, galaxies collided, planets formed, all without witnesses. The universe simply was, following the laws of physics, indifferent and unobserved. But then, through a series of unlikely events, complexity emerged. Simple molecules became complex ones. Self-replicating molecules became cells. Cells became organisms. Organisms evolved brains. And brains, eventually, became conscious. On at least one planet, and possibly many others, the universe produced beings capable of looking back at it. Capable of asking, where did we come from? How does this work? What does it mean? You are one of those beings. You are made of atoms forged in the cores of dying stars billions of years ago. You are assembled from matter that has existed since the Big Bang, briefly organized into a pattern capable of thought, emotion, and wonder. For a moment, a cosmically brief, but subjectively rich moment, you exist. You are aware. You can look up at the stars and understand that you're looking at ancient light, photons that have traveled for millions or billions of years to reach your eyes. According to neuroscience research from institutions like MIT and Harvard, consciousness, whatever it is, emerges from the interactions of billions of neurons, themselves made of atoms that once floated in interstellar space. Your thoughts, your memories, your sense of self are all patterns of electrical and chemical activity, in a 3-pound mass of tissue that the universe somehow created. That's astonishing. And here's the paradox. You are insignificant in duration, but not in experience. Your life might last only 0.0% of cosmic history, but during that time, you experience richness, complexity, meaning. You feel love, wonder, curiosity, joy, sorrow. You create art, music, literature. You ask questions about the nature of reality. You form relationships, build communities, pass knowledge to future generations. None of this is significant to the universe, which will continue indifferently whether you exist or not, but it's significant to you. And perhaps that's enough. Philosopher Thomas Nagel, in his essay The Absurd, argues that the conflict between the cosmic insignificance of our lives and the seriousness with which we take them creates a kind of absurdity. But rather than leading to despair, this absurdity can be liberating. If nothing ultimately matters on cosmic scales, then you're free to create your own meaning, to decide what matters to you. The James Webb Space Telescope captures images of galaxies billions of light years away, showing us the universe's vastness and our smallness within it. But those images exist because humans built the telescope, launched it into space, and trained it on the heavens. We might be brief, but we're capable of understanding our context, of seeing ourselves as part of a larger story. ESA's Gaia mission maps 1 billion stars, revealing the structure of the Milky Way. That knowledge doesn't change the fact that we're temporary, but it shows that during our brief existence, we can learn, discover, and understand. We can take the matter the universe has given us and use it to comprehend the very laws that govern that matter. As physicist Richard Feynman said, the same atoms that make up your body once belonged to stars. You are literally made of stardust. That connection, that continuity, links you to the cosmos. You're not separate from the universe. You're part of it. A temporary, brief part, but part nonetheless. And there's beauty in brevity. According to Japanese philosophy, the concept of mono-no aware refers to the bittersweet awareness of impermanence, the recognition that things are more beautiful because they don't last. Cherry blossoms are cherished precisely because they bloom for only a few weeks. Would they be as meaningful if they bloomed year-round, forever? Your life is the same. It's precious because it's finite. Every moment matters because you have so few of them. The fact that you're a cosmic blink doesn't diminish your experience. If anything, it intensifies it. Moreover, you're connected to others. Humanity might be recent and brief, but we're here together. The knowledge you gain, the love you share, the art you create, it affects others, ripples outward, contributes to something larger than yourself. You might be insignificant to the universe, but you're not insignificant to the people around you. And there's one more thing to consider. We don't know if consciousness is rare or common. According to the Drake equation and ongoing SETI research, there might be countless other civilizations in the universe, each experiencing their own cosmic blink. If so, then consciousness, though brief in any one location, might be a recurring feature of the cosmos, appearing again and again on different worlds, in different eras. You might be temporally negligible, but consciousness itself might not be. It might be one of the ways the universe explores itself, generates meaning, creates beauty. You are one instance of that process, one brief flame in a cosmos that might be filled with countless others. So what does it mean to be a cosmic blink? It means you're temporary, insignificant on cosmic scales, and utterly irrelevant to the universe's future. But it also means you're here now, conscious, capable of understanding your place in time, capable of experiencing wonder at your own existence. It means that your life, brief as it is the only life you have. Those 80 years, those 29,200 days, those 700 to 800 hours, that's it. You don't get a second chance. You don't get to pause the cosmic clock and catch your breath. Time flows on indifferent, and you flow with it, from birth to death in less than a cosmic heartbeat. But during that heartbeat, you're alive. And that, perhaps, is the only meaning you need. Conclusion: the mathematics of meaning. So we return to where we began. A human lifetime is 0.08% of cosmic history. We've existed as a species for 0.027% of the universe's age. We're recent, temporary, and insignificant. We are mathematical errors on an infinite timeline, rounding errors in the universe's calculations. But we're also conscious, we're aware. We can contemplate our own insignificance and find meaning despite it. We can look up at the stars, understand that we're made of the same atoms, and feel a sense of connection to something vast and ancient. The universe doesn't need us. It existed without us for 13.8 billion years and will continue without us for trillions more. But during our brief appearance, we can observe, wonder, love, create, and understand. We can take the matter we're made of and arrange it into art, science, relationships, ideas. That's what it means to be human. To exist for a cosmic blink and to make that blink matter, at least to ourselves and to each other. The universe might not care, but we do. And in the end, that's enough. As you drift off tonight, remember this: you are temporally insignificant, a mathematical error, a blip on an infinite timeline. But you're also a rare and precious thing, a piece of the universe that has become aware of itself. For 80 years, maybe less, you get to experience existence, to feel, to think, to wonder. And when you're gone, the atoms that made you will continue, recycled into new forms, part of the ongoing story of matter and energy. You are brief, but you are here, and that is extraordinary. If this quiet journey has brought you even a small moment of peace, I'm deeply grateful you've spent it here with me. A gentle like or a soft tap on subscribe means more than you can imagine. It's what keeps me creating these cosmic lullabies for wandering minds like yours. And if you're kind enough, please tell me in the comments where you are tonight and what time it is where you're listening. I love seeing how far these quiet adventures drift across the world, from one sleepy corner of the planet to another. Your words, your presence, even your silence, they're like little stars guiding me forward, and I treasure them deeply. Until next time, may the brevity of your existence remind you to cherish each moment. May your cosmic insignificance liberate you from needless worry, and may you rest easy knowing that here, now, in this impossibly brief instant, you are alive, aware, and part of something vast, ancient, and endlessly beautiful. You are a cosmic blink, but you are a conscious one, and that makes all the difference.